Me? Cool.
Hey, this is Anna.
It's Ari.
She writes code.
Ari writes books.
On code.
That's Ginger, Ari's dog. She doesn't write books or code, but she's cute, so.
She motivates it.
So we're here to talk a little bit today about how Elixir helps us write better software.
So we're going to talk about we're talking about an app that we developed called Elixir. Elixir is a semi-real-time system where we pull data from Twitter, and we're gonna talk specifically about what actually went into Elixir, and you'll see why when we get into it. Okay.
So a little bit of background. We were able to do this pretty quickly. It took us about a day and a half to get to a real-time system. We're using a Twitter library, sockets, and a little bit of React, but no framework, really, just Elixir. And how did we accomplish that? Or what did we do? And why is this beneficial?
So Elixir really gives us there's a lot of power that we get from the language of Elixir. A lot of that comes from Erlang. A lot of that comes from specifically from Elixir. So one of those features that we embrace is the umbrella app design. So when we're building any application, regardless of the language, the way that in my opinion, that good apps are developed are done through design-driven development. That is, you take what you are building and you break it up into small modules and you follow that design as you're building. Elixir, the ability to build an umbrella app, which is a single monolithic app broken up into little parts, kind of forces that. In order for you to actually build a quality application, you're forced to look at the divisions of the functionality of your application. So the umbrella app gives us the ability to break up our functionality into little parts. It also allows the management of dependencies to be independent of each other, so you might have one part of your application that uses a specific dependency or a specific version of a dependency, and another uses a completely different version of that dependency. Breaking up into an umbrella app allows you to work with both of those pretty easily. The dependency resolution and dependency conflicts are minimized. And also, wow, this is a run-on sentence. And also, and. I'm going to finish that sentence and go to the next one. Okay. Umbrella apps also make test-driven development and behavior-driven development pretty easy. So I like to say that you get some of the benefits of building a monolithic app while still getting some of the benefits of building a microservices in the same app.
So to build this app, what did we decide we needed? How are we going to do this in a way where we could harness the power of Elixir? So we decided that we needed something that was going to pull from Twitter. We needed a web interface to show the tweets that we pulled from Twitter and somewhere to store them. It's a database. So let's get started. So we used the Mix build tool to create our app. It's a really powerful tool. It makes it really easy. If you look at our current app, we basically passed a new command to Mix with the name of our app and the umbrella flag. And you can see our 3 child sub-apps, the DB app, the Twitter app, and the web app. So let's take a look at how we set up our DB app. It's going to save tweets from the database and then update the vote count, or when people have favorited a tweet, it'll update that so we can see how many times it's been favorited. So to start, we need to grab our dependencies. We're using Postgres and Ecto. Ecto is kind of like ORM, similar to Active Record, for those of you that are familiar. So we pull those into our app. We run mix steps get to retrieve those. And Mix, as Ari mentioned, makes it really, really easy to manage dependencies. And that's important, right? It means conflict is a lot less likely, and when there is conflict, it makes it a lot easier to resolve. And smarter tools allow us to build smarter apps. #SmarterTools, Twitter themed.
Feel free to tweet it.
So what else comes with smarter apps?
So when we're talking about smarter applications, one of the things that we're talking specifically about is applications that come with stability. So one of the ways that we appreciate stability inside of an application, regardless of the language that we're talking about, is doing test-driven or at least test behind. So as you're writing your functionality, you're writing your tests that go along with that. So you can have the stability and confidence that your application is going to work the way that you expect it to. Just ask Dave. He's here.
Actually, I think he's in the room, so you could ask him.
You could ask him. You could ask him. So in Elixir, one of the really awesome things about Elixir is testing is core to the actual language itself. So unlike some other languages where you have to pull in your testing frameworks, when you use Elixir, you get XUnit for free because it's built in. So let's take a look at what that might look like. Or let's actually take a look at what that did look like as we were building our application. One of the features of our application that we want to ensure works as we expect is that the vote count is set accurately based on what we get back from Twitter. So we can ensure that that is the behavior that we expect because, or through writing a test. So let's write the test. We'll write the test first. Not only when we're writing a unit test are we writing the test to ensure that functionality works, but we're also writing the interface that we want our application to adhere to. So for that test, we're writing a function that does first or create.
Sorry, too fast.
That's okay. I'm actually done with that one now.
Okay.
So we'll write that test. We'll run that test, although we don't need to because we know it's going to fail because we haven't written the functionality yet. So then, knowing that our interface and the expected output of that test matches our expectations, then we can go ahead and write that functionality and get that test to turn from red to green. So we implement it, then we run the test again because we want to see if we implemented it correctly. And it looks like we did. And this gives us the confidence to know that our code is working. Do I need this?
Yeah, that's for the camera.
Oh, okay. Great.
So before we move on to the Twitter app, I want to talk about a look at pattern matching, which is a term you hear a lot in Elixir, and it's powerful, but why? Let's take a look at an example. You saw that we were saving tweets to the database. And if you look here, we have two versions of this one function with the same name. But if you look closely, you'll notice that they each have different arguments being passed in, right? So we have two cases here. Either we have a tweet that's already been created, and we just need to return it, or we haven't, and we do need to create it and save it to the database. So the function that gets executed is the one whose arguments match the data that's being passed in, or the data matches the arguments that are set in the function. So why is this important? It makes it really easy to understand what's going on. You look at each function, it's really clear what you're declaring. Again, as I said, our code's declarative, right? You're being really intentional, and you're focusing on what data you're inputting into the function. It prevents complicated conditionals, right? We're able to decompose our functions. You're not looking at long strains of logic to figure out what's happening where. And it allows you to deal with, again, as I said, data in really small pieces. We can write really small and focused functions, which makes our programs overall a lot more clear. So let's take a look at our Twitter app. We have a high-level diagram. We have Twitter. We're streaming from Twitter. We're saving to the database. And then we're sending it to our web UI. So let's implement the Twitter streamer. And again, somebody mentioned this morning there was a talk about Twitter and rate limiting. It's a thing. So we're going to try not to get banned. So we're going to pull from Twitter. Elixir, somebody mentioned again in the talk this morning, it was really challenging to do this in Erlang. Somebody wrote a pretty great library called xTwitter that's easy to use at parity, whoever you are. If you're here, love to meet you. So thank you. So it's really straightforward. We pass our parameters in this case, hashtag ElixirBot. Then we're going to, we can also pass in options, how many tweets we want to pull at one time. We're going to save them, and then we're going to send those tweets off to our web UI.
So we could do this using one function, right? Our semi-complex application could work in the flow function, and we could pull our tweets and do our database manipulation and then throw those up to the website. Well, there are some problems with that. One, that's really complex to test. It's really hard to isolate those features. It also mixes a bunch of concerns, like when you're dealing with the database versus when you're dealing with Twitter. And what happens if your database fails? How do you know that it's your database that's failing and not Twitter? Because you have everything written in that single function. So, Anna, is there a better way to do this?
There is a better way. Some of you may have heard recently about Jenstage, which it's a behavior that allows us to do a pipeline of work, essentially, and allow independent steps to happen in independent processes. So again, let's look at our design. Seems like it would be great for this to happen in our app, right? We have a process where we're doing something with Twitter, we have a process where we're doing something with the database, and we have a process where we're doing something with the web. Yeah, what happened if we flipped the direction of the flow? And why would we want to do that? So what happens when there's more coming into your system than your system can handle, right? We want to rate limit Twitter, so A, we don't get banned, but B, we're not constantly consuming, and maybe our consumer can't handle everything that we're putting into our system. Anybody like I Love Lucy? Just me? Okay. So Jenstage actually allows you to go backwards. What does that mean? Well, there's this concept of back pressure, which allows us to have control. And I'll explain that in a second. Again, looking at our diagram, we're going to have three processes: Twitter, our database, and our web process. And how is this backward system set up? So we have three processes, and Jenstage has three roles that you can assign to a process: a producer, which acts as a source; a producer-consumer, which can act as a source or a sink; and a consumer, which can act as a sink, and it'll receive processes at the very end. It'll be at the very end of your pipeline, so to speak. So if we look at our diagram, the way we set it up is we do have Twitter pulling, we have the database, and we have the consumer. But the interesting thing about Jenstage is it actually allows the consumer, the thing sitting at the end, to tell the producer, I only want you to pull in this much. I only want you to pull in this many tweets. And since we want to control our desires, aka manage demand pressure, we have a callback once we're started that we can tell our Twitter app, hey, only do this much, this often. And then Twitter will pull some tweets, we'll save them, process them in the database, and then we'll send them off to our UI. Our DB producer consumer sits on top of the web app, or in the middle, so it'll receive tweets, it'll save them, and it'll send them off again. And it comes with a really nice callback. Once it's done process, once it receives it, it does its thing, and then it sends them off. This handle events callback at the end will send them off to the process that's subscribed to it, which is our web process. Now, back to the tweets. So we get to the top, and we have this handle demand callback from our producer. And you notice the first argument's demand. That's actually going to come from the process at the very end that's saying, oh no, I only want you to pull in this much stuff. But there's one piece missing.
Okay, so in Elixir bot, it's kind of only useful if we have a web front end, at least this version of the app is. So in order to do that, we're going to use the fantastic Cowboy library, which is written in Erlang. You may or may not have used Cowboy. If you have used Cowboy, it's awesome in either Elixir or Erlang. We'll go ahead and we'll pull that dependency. Again, thank you, Mix, for making it really easy and awesome. Then we'll set it up. In our implementation, we have two endpoints. We have the root endpoint, which we'll talk about, and we have a WebSocket endpoint, which we'll also talk about. That's superfluous. All right, so let's talk real quick about the router. The router is the part of the application that serves all the index.html and the JavaScript. This is actually the entire implementation of the router. One thing that's really cool about this is because we're building a single page app, we don't have any extra routes that we have to support. So in a single page app, we're taking any request that comes in that does not match a request or a file that's on disk, we're sending the index.html. Everything else, we're just sending whatever file matches on disk. Thank you to Erlang and Elixir for making the EEX library come with Elixir, because EEX, if you're unfamiliar, is a templating library that allows us to write templates. That's silly. It's a templating library. One of the cool features about that is the fact that we can, in a different environment in Elixir, we can send back different pieces. We can send back different pieces of HTML. So if you look at this code, we're under development circumstances, we're sending back a Webpack 2 served application, which allows us to do hot reloading inside of our app as we're developing. Because we're doing hot reloading, that makes development really easy and really fast. Under production circumstances, we can we'll send back the built version of the app. And notice we don't have to change anything. There's no extra Webpack files, which if you've ever used Webpack, that's kind of annoying. And there's no extra index.html files. So we're using React and Webpack 2. This is how hot reloading is set up. We're also using Redux because all the cool kids are using Redux. Raise your hand if you know what Redux is. So Redux is a data library that makes handling data on the front end really easy and really quick. Okay, so moving on to the other interface of our application, we have WebSockets built into our library. On the client, we'll connect to our WebSockets at /ws, stands for WebSockets. And when we're connected, then we'll listen for any data packets that come from our web server. And this also allows us to send, it's bidirectional. So what are we connecting to? This is the Cowboy WebSocket behavior handler that we're using. The Cowboy WebSocket behavior handler is really nice. It allows us to treat our WebSockets as though they are Elixir or Erlang processes. We can kind of treat it just like it's a gen server. So we'll implement the callbacks, and we'll get those callbacks when we get something from the application's front end. So sending data from the client to the server is really easy. We're just using socket, the native socket send. This is a native HTTP WebSocket. And on that WebSocket handle side, we'll listen for messages that come in. Presumably you'd want to use something like pattern matching here, but for brevity and simplicity, you could listen to your messages just like this. However, broadcasting to our connected clients is a little bit more tricky. In order to do that, we need to keep track of all the connected clients that are connected to our application. I just said it was tricky, but I kind of lied, because it's actually really easy to do using Elixir and the Elixir registry. The Elixir registry, if you're familiar with gproc, it's like the Elixir version of gproc. If you're not familiar with gproc, it's basically kind of a shared dictionary. This is really high level. It's a shared dictionary that allows us to register keys in a state, multiple keys in a state, so we can register our different processes for different keys that we want to look up. So for instance, we have a registry here that is named WS registry for WebSocket registry. When our WebSocket client connects, we'll subscribe to that registry with that process ID. And then all we need to do is send along our broadcasts to every client that is connected under a specific name in the registry. And then we handle everything using the normal Redux Webflow. So for instance, we are listening for received tweets. That's the only message that our only message that our application is dealing with are new tweets. We'll receive those tweets, and then we'll do something on the front end. In this case, we're just storing that in a list, and the rest of our React application works the rest of the way that a React application works. Okay. Any questions? Yeah.
So I don't have a lot of background with Elixir or Erlang. What parts of this, you mentioned at the beginning, this would have been harder to implement in Erlang. What parts of it would have been
To do in Erlang? I'll let Anna ask that question or answer that. Well, we did use, well, that's for one. You don't get Ecto, you don't get Phoenix, you don't get the Mix build tool, although I think you can use Mix with Erlang. I've never done it. I don't know how you would. So you lose out on Mix, you lose out on that functionality. You still have to build a testing library with Erlang.
And to give a little background, this wasn't necessarily like we're doing this in Elixir because it's harder to do in Erlang. We were showing like how powerful this would be to do in Elixir as opposed to maybe other languages that we've worked in the past.
And also how it enforces good.
And how the language itself, because of how Elixir works, and a lot of things it does receive from Erlang, why it helps you develop good practices as you're building an application, or forces you to.
So to follow up on that, I would ask, how did Elixir make you guys better programmers?
Well, I've just always been a good software developer. No, I'm just kidding. That was a joke. I'm a terrible software developer. This code is going open source, so you'll be able to judge that for yourself. I mean, it is open source, actually. So, how did it make us better software developers? Well, as we kind of mentioned through the talk, Elixir gives us practice over good development processes, such as test-driven development. It makes it really easy to do that. So rather than having to spend a bunch of time setting up your JavaScript testing library so that it works against, so you're setting up all your mocks and test library setup harness, and your test harness is all nice. You can do that pretty much for free without any extra work. So the pressure of having to write a test is a lot. It's a lot less. The pressure of writing a test. That's not what I meant to say. The bar for writing a test is a lot lower. Design-driven development under Umbrella apps, I don't know how you would do that in another language without a lot of setup.
I mean, I think a lot of it at a little bit even more of a higher level, and I have not been working with, I'm really interested in Elixir, and I'm really interested in learning more about Erlang. I haven't been working with Elixir that long, but it's interesting that some of the constructs in the language, at least to me, kind of really force you to be intentional, force you to think about how you're setting up your application. They really force you to think about how you're composing your functions, how you're working with your data. And I feel like sometimes, even though we are intentional, we will always want to be intentional. In other languages, it's easy to sometimes lose sight of that. And I think Elixir helps reinforce that.
Also, immutability. I'll go back down a little lower level. The immutability, the fact that you're sending data and you're creating new instances of data, and you're not sharing that data. This is one of the reasons why I like Redux a lot. The fact that you have to do that in order to actually work with the language itself. It's really nice that you're not going to end up munging a globally shared data object, because there's only one way to manipulate data, and that is create new instances of it.
And I think one more thought, just higher level, is that we didn't touch upon this as much because we want to touch about how the language makes us better developers, but the community is really active. The open source community is really active. There's a lot of support. People are really willing to answer questions. And there's a lot of information and resources out there to help. So.
Speaking of which, if you do want to participate in that, there's two opportunities that
Are there any more questions?
Are there any questions?
Any more questions?
We'll be around if there are, and that's how you get a hold of us on Twitter.
Do you want this?
Yeah, so there's two opportunities.
There's a question. Hannah?
Oh, yeah.
Yeah, so I'm just curious, I think that you guys are, talking about, the value that Elixir provides in teaching, essentially forcing you into good programming practices, that particularly if you're coming from the web space, you may or may not have been forced into in the past. How do you think, I'm just curious, how do you think you sell it to those folks? How do you get folks who are, not on board with these things, be like, oh, I'm going to actually force myself into these
That's a really good question. How do you sell good development practices up the chain to people who don't, either to people who don't use the language, don't currently use the language, or people that are hiring people to use the language? Is that, yeah?
Yes. Do you have an answer? Oh, no.
Yeah.
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 You don't, you never sell. You just make it the easiest way to do something. And that's the benefit, I think, of a lot of the stuff you've been talking about, is that it's the natural way to do it in this environment. And so you tend to fall into those practices.
But I think, yes, I totally agree with you. That's like the business model of Dropbox, right? It's really easy to use Dropbox, so it's bottom up. But you do have there are also cases for when you want to bring something into a company, because if you want to bring it into a company, you do have to do some selling, so to speak, and you do that. I think you're right to augment or to add to what you just said. You make it super quick to write tests and super easy to divide up your app in pieces. And that's what Elixir, that was actually the core function of this talk. So the way that you sell it is you make it really easy, and you make that the prototyping process really flexible.
Of course you do, sure.
Because I'm kind of irritated by the fact that you sell something on ease reuse rather than quality of the result.
No, but the point.
Because I think you should actually sell the quality of the result. I don't mind. I hate Markdown because the quality of the result is poor. I love tech because the quality of the result is good. I don't care the fact that it's wonderful. Yes, but I'm looking at the ultimate quality of the final thing. But if you've got to do lots of tricky things to make something that's beautiful, you've got to do it.
Okay. So we're totally going to devolve into this discussion, and I'm very happy to do it, but I want to make sure that I share the two opportunities that we have. We do Elixir Bridge, where we help facilitate learning Elixir and Erlang and Phoenix. We have a couple different tracks already.
Yes, Sarah mentioned it this morning. It's a series, if any of you are familiar with Railsbridge, series of workshops. They're free, day-long workshops, and the goal is to make it easy for people who are interested to have a space where they can learn. So if you're interested, come talk to us about it.
And then we're also writing a book on Elixir, a community-driven book on Elixir called Full Stack Elixir. Tweet at me if you want more information or you would like to get involved in the book. We like I said, we like to have a bunch of different people collaborate.
I have one more question before we
Yeah.
get into philosophy. Were there any, you talked about some of the ways that Elixir made you better programmers. Are there any ways, any pitfalls or any ways that you found yourself doing really bad programming or falling into?
I wouldn't say maybe, and I also, as I do more, potentially, I wouldn't say bad, but to think about Joe's point, it does make things really easy in certain ways, but it took me some time to understand some of the concepts, right? So, I had to be okay with being a little bit frustrated about how supervision trees work, or some of the other, or Jenstage, or how some of these concepts work, to really understand how powerful they are. And so it took a little bit of time of being frustrated and being okay with that, because I was trying to understand this tool that allows you to do this really powerful work. I don't know what your experience is. Ari's been writing Erlang and Elixir a lot longer.
I don't have a good answer for that yet. But I know you, Ryan, so we'll hang out later and I'll answer it for you later. And for you on the live stream or looking at this later, that's my Twitter handle. So feel free to tweet at me.
Cool.
Or her. Cool. Thanks.
Thank you.